Hello guys, welcome back to the channel for another Databricks video. Today we are going to see the two most important things we need to know about Spark as data engineers. That is Spark architecture and Spark optimization. Why are those two so important? Because as developers, it's beneficial to understand how Spark works under the hood and what happens with our queries and our data frames. There is no need to be an expert. It is good enough to have an overall idea of what is happening behind the scenes. Recently, I took the Databricks courses for data engineers, and I think it's a good time to summarize what I have learned from them. I'm planning to make more videos about Spark and Databricks. There is a lot of demand for Databricks knowledge in the market right now, and so hopefully some of you find those videos insightful and helpful. There is no code in this video, unfortunately. I know you like hands-on. It's only theory, and that's why I will try to keep it short and to the point. So this is the typical Spark architecture. We have the driver node that creates a Spark context that we interact with when we write a program, and then it splits the tasks, the jobs, into various tasks that assigns to the worker nodes. Now, as you can see here, we have one driver node and four worker nodes, and each worker node has an executor, which is nothing else than a JVM. And those worker nodes actually execute the tasks and they return the result to the driver node where we can see the results. For example, here we have one driver node and four working nodes, and each node has the executor and it has two cores, all tasks, the same thing. So here four working nodes and eight cores. And this is a very typical Spark architecture. The cores execute the tasks and they return the result to the driver. In a nutshell, this is the Spark architecture and how things work behind the scenes. Then we have narrow and wide transformations. Narrow transformations are the ones that start with one partition and they stay with one partition. For example, we have select, filter, cast, union. All those transformations start with one partition and they end with one partition. But here, when we have wide transformations, on the other hand, they are those transformations that we have to that they call shuffle, and we have to redistribute the data to new partitions. For example, if you look here in the diagram, we have the first partition has three colors: red, green, and blue. The same with the second partition and with the third partition here. Now, if we group by color, as you can see, we will end with a new partition in the end, which has only red color, and with the second partition only with the green ones, and with the third partition only with the blue ones. But but group by is a transformation that caused shuffle, right? We had to take the colors from all those partitions and group them together. So that's the difference between narrow transformations and wide transformations. And now we will see an example for both those two. Let's start with a narrow transformation. That would be filtering. In our case, we will see how to filter our data. So for example, here we have one driver node that we can imagine he's the teacher in our case, and then we have the students at the bottom. So each desk represents a working node, and each desk has two students, or course in our case, when it comes to Spark, right? So the purpose here is to filter out the brown pieces from those candy bars. What does the teacher do? It assigns tasks to the students, of course, right? So student A gets back 1, student B gets back 2, student C gets back 3. So we have 12 students, one teacher that he assigns tasks to the students. In the next slide, as you can see, the students are working on their tasks individually. And some of them finish faster than the other ones, right? And they remain idle. So what does the teacher do? He assigns more tasks to the students. So students A, E, H, and J, they get the rest of the bugs. while the other students are still working on their first task. As you can observe, the students with the first round of tasks finished, but now we have to wait for the students with the second round of tasks to finish as well. Otherwise, the job is not done. Eventually, everyone is done and they return the results to the teacher. Or in our case, they return the results to the driver node. And this is how things work. A practical example of an arrow transformation would be to filter out some data from a calendar dimension table. So I have a calendar dimension table, a typical calendar dimension table. In my Hive metastore, we have 5 columns: date key, date, week key, period key, year, etc., etc. And we want to filter out this date key. And we use .collect to actually return the results back to the driver node. As you can see, that spawned one job, one stage, and 8 tasks. But we started with 8 memory partitions, as you can see here, and we finished with 8 memory partitions. And there was no shuffling whatsoever. We started with one partition, we filtered out the data, and we ended with one partition with the data that we want. But there was no shuffling whatsoever. So that's an example, a very simple example of a narrow transformation. Let's move to an example of wide transformation. And we are going to perform a global count. For example, here in our case again, we have the teacher and the students, and the teacher wants to count the total pieces in those candy bags. So what he does, he assigns students B, E, I, and L those 4 bags. And the students perform the task, they start counting, and they commit their findings, right? So student B found that the pieces in his bag was 5. Student I has counted 4 pieces. Student E counted 6 pieces, and student L counted 5 pieces, right? Now the driver says, student Z fetch the counts from the other students and perform a total count. So student Z here performs a total count, and he returns the results to the teacher, to the driver node. That would be 20 in our case. But in order to do that, as you can see, we had to shuffle the data between students, right? And this is why it's a wide transformation, because we had to shuffle the data and redistribute the data into new partitions. Another example is the group by transformation. As you can see here, for those 2 partitions, we group by color for each partition here, and then we have the rest of the partitions as well that we group by color, but then we need to perform a total group by, right, to get all the green partitions into one partition. So at stage 2, we perform a global group by, the same for the red partitions and the yellow partitions. So that's why it is a wide transformation. We have to shuffle the data around. In a more practical example, as you can see, we are going to use the same dimension table that we used before. We are going to filter out the year that we don't want, but we are also going to group by year and get the results back to the driver node using .collect. But this time, as you can see, we spawned 2 jobs, right? Job 18 and job 19. And as you can see here at the end, in the first stage, we shuffled the data, and we did the same with in the next stage as well. So this is, you can see that group by caused shuffling. Moving on, we have the second most important thing we need to know about Spark, and that is query optimization and performance. Here you can see a diagram of the query optimization with adaptive query execution. You can find this diagram everywhere on the internet, so don't worry about that. But as you can see, when we submit a query, the first step is the unresolved logical plan, which essentially checks whether the schema is correct. And then the next step is the metadata catalog, which adds the data types. And we create our logical plan. Now, the Catalyst Optimizer is using rules like moving filter before join to produce an optimized logical plan. So the purpose of the Catalyst Optimizer is to produce an optimized logical plan. And based on this optimized logical plan, we create multiple physical plans using different join strategies, data skipping, predicate push down, etc., etc. And the cost model picks the physical plan with the lowest cost. And then at this point, after the cost model, the cost-based optimization, we get the selected physical plan, which is in Java bytecode. It does not matter if the input is a data frame or an SQL query. In the end, everything is converting into an RDD. But then we also have the adaptive query execution, which looks at the statistics, and if there's and if the number of shuffles is large, it feeds back to the Catalyst optimizer to fine-tune it even more. So there is a lot of optimization going on, logical optimization, cost-based optimization, and if there is a lot of something, then we feed it back to the Catalyst optimizer once again. There is a lot of optimization going on here in order to achieve the best performance. On a more practical level now, let's say we have two data frames. One that, again, we load the dimension table and we filter out year 2023, and the second data frame that we filter out year 2022. And we join those two data frames based on the date key, and we also want only the data for year 2021. As you can see at the end, I used .explain extended to see the logical plan and the physical plan. So as you can see here, in the past logical plan, the filter is after the join. So we join first here, inner join as you can see, and then we filter for year 2021. In the analyzed logical plan, we add data types, right? So you can see the date key, integer, date, etc., etc. So we add the data types here. And in the optimized logical plan, as we said, we perform optimizations and we move, as you can see, the filter before the join. Now the filter is inside here. You can see, and year is 2021. So this is how it optimizes our queries, right? And how it achieves better performance. This was a quick summary of Spark architecture and Spark optimization. Some of the diagrams are taken from the Databricks Academy courses. This is the link. You will find it in the description as well. Please check it out. I do not own any of those slides. I just use them for educational purposes. If you want to know more about Spark and Databricks, please check Databricks courses. If you like the video, please click the like button, leave a comment and subscribe to the channel, and I will see you in the next one. Thank you for watching.